Hey, everybody, and welcome to another episode of Adventures in Machine Learning. This week on our panel, we have Gant Laborde.
Hello.
I'm Charles Max Wood from devchat.tv. Quick shout out, I am working on Max Coders. So if you're looking to have a successful career, meaningful life, that's what we're talking about. So all the skills you need to do that stuff. We also have a special guest this week, and that's Robert Plummer.
Hey, how's it going?
Are you a software engineer trying to learn machine learning? Then you should check out the course from educative.io called Machine Learning for Software Engineers. It has 87 lessons, 8 quizzes, 115 challenges, 163 playgrounds, and 2 code snippets. In other words, it's not just a set of videos that tell you how to do the thing. It actually walks you through all of the processes for machine learning. It gives you quizzes, it makes you do challenges, it's very hands-on. It's done with experts from companies like Google, Microsoft, Amazon, and Apple. And it is a terrific course that I've been learning to do machine learning. So go check it out at devchat.tv/learnml. That's devchat.tv/learnml. And that'll take you to the right place so you can sign up for the course. It's going. Do you want to introduce yourself real quick? Let us know why you're world famous and all that stuff.
Yeah, I'm Robert Plummer. I code. I got interested in machine learning a few years back, and I guess I don't know what to say, actually.
It's all good. We'll prompt you a little bit.
Okay.
Robert the modest guy.
Yeah. And Eric's also here now. So Eric, do you want to just say hello?
Yeah, I'd love to. How are you doing?
Doing good. All right. So Robert, I think some of the introduction is just going to come through what we're talking about, but I'm a little curious, after reading your blog post, what's your background? Because, I think I read JavaScript a whole bunch in here. And
yeah, my background, I'm really interested in taking things apart. It's something I got in trouble for growing up and knowing how things worked. Like a drill shouldn't be magic, right? Like it's, how a drill works or, whatever the thing is. So my background is that I like to take things apart and actually see how they work on almost like an atomic level. And I didn't go to college. I went to high school, and actually, like, when I was presented with college, I was like, but you guys are doing curriculums of things that are already built or that have been built for some time, which means that by the time that I learned about it, it would be out of date. I knew I wanted to do software engineering because I took a spreadsheet of all the incomes that, like starting income and flexibility, and I sorted them by like the most flexible and the highest income. And software engineering was at the top. And so I was like, great, I'll do that. And I'm not going to go to college because I can go right to the workforce and just start learning. And I was fortunate enough to get a job and do that. And I've had some success doing that and started contributing to the open source world. That's my background.
Nice. So Robert is a nerd and used a spreadsheet to choose his career path. And then how did you get into machine learning?
Well, I mean, you hear about it. It's like the next big thing for quite a few years. That was like, I was interested in it. And every once in a while, I look into some algorithms or just the mathematical equations as to how something worked, and looked at some libraries along the way. But I don't know. I always felt that the equation that you see is always like way simple, and the libraries are not.
Mm-hmm.
And when I saw that, the difference, I mean, like, they're not just like libraries a little bit complex. It's like so complex, you have no idea what's going on there. It would take you, I mean, you have to study it and pull it apart, and just, they're so vastly different. And I think that's where I felt like compelled, let's make them match up. Let's get them closer, so that all of a sudden the math is the library.
I like that. It's interesting because you kind of go into that in this blog post. And yeah, you mentioned a few other things. I've kind of played with building neural networks in my favorite programming languages, but they have like 4 nodes in them, right? It's not going to do a whole lot of useful stuff. And yeah, that's kind of the deal. Is I look at it and I'm like, okay, so how do I get from here to building something that people are actually going to want to use, right? Get to a model
Absolutely.
where I'm going to be like, yeah, see how useful this is? It solves your problem. But then it gets complicated really fast. So I really like this approach. Do you want to just kind of summarize the article for us, and then I'll stop talking and let the panel chime in?
Well, yeah, sure. He mentioned that you guys have a, what do you call this?
Super awesome crew of podcasts.
Yes, there you go.
Ooh, yeah.
We have the super awesome podcast. And I was like, and I pulled up the doc that you guys gave me that mentioned, like write something about something to prepare for the show, and just started writing. And it had been an idea I was tossing around for some time, but the whole thing is, if we're trying to if we're trying to make, well, first off, JavaScript is exploding, and by relation, anything that's JavaScript, or rather that compiles into JavaScript. So TypeScript would be included in that. I don't know, anything that compiles into JavaScript. So the point is JavaScript's exploding, and it's the most ubiquitous language. It's everywhere. And it didn't have, at the time of my interest being piqued, the tools for machine learning. And because JavaScript in itself is kind of like a language, it's not about itself. That's kind of like a thing that I like, I guess, plug for JavaScript. There's a lot of languages that are like, this is the language where you can do all these other things. Well, JavaScript's like, well, here's this very basic language. And because we keep it basic, it allows for all those other things. It was a perfect place for machine learning to sort of reside. And there's also an antagonist in the article who shall remain unnamed because I don't know his name or her name. That was just like a motivating factor. Okay, so machine learning is missing in the most ubiquitous language. Let's put it there. Time is when, right? Time would be now. And who should do it? Well, I guess I'm here, so why not just it be me? And, famous last words. But the point was that there were some attempts with JavaScript, but a lot of those things were like toys because they just didn't have the performant capabilities that were needed for them to be an enterprise-ready tool. And so it was kind of a two-for-one sort of deal. You venture into taking full control over the resources in the computer so that you could build a not toy in JavaScript for machine learning. And so far, we've able to produce an alpha for the machine learning part. For the graphics processing part, we have a very solid basis for almost every single device, for browsers and for even native implementations using the graphics processor, even Node, which is really important. And so that's with the GPU.js. And then Brain.js takes advantage of GPU.js as a platform so that we can write those very simple equations that, it looks almost like you would see a professor write on a chalkboard, emulate that right onto the graphics processor, and only be like just one or two layers. Well, let me say like 3 layers of abstraction deep, which is like using the layers and the neural net. And you can click into and look at those layers and actually see the math behind them, and it's not just so abstracted away you can't find it. So that's the journey.
So you mentioned a couple of things that you glided over that I know personally you've actually had significant influence on. So I want to go back to those for a second here. GPU.js, which is a really awesome thing, and honestly, I don't know anything about GPU accelerated code. I wouldn't even know how to say, oh yeah, no problem. Now JavaScript goes everywhere. Just go ahead and stick it in the GPU. Like, I think I would have been like, I'm going to go somewhere else for a minute here. And if I don't come back, I'm okay. But actually, you jumped in, right? So there's GPU.js, version Cosmic Jellyfish. It's coming out. You had a significant part in like kind of jumping in and participating with that. Can you speak a little bit about that part first?
Sure. So glossing over is a key term there because I've spent the last year basically neck deep in the thing.
That's significant to give that tool. I mean, that's a powerful tool for the community, for everybody, not just machine learning. That's for a lot of people.
I was going to say, is it open source, and can I mine cryptocurrency with it?
Yes, you can. And there are people doing it.
I'm going to be rich tomorrow.
Well, what we really want to do is we want to build. I'll get into the like what it is, what it does in a minute. But like we really want to do with it is we want to take advantage of like tensors inside of like NVIDIA cards, and so you can like do cryptocurrency. Like nice. Without any penalty with JavaScript. So you have JavaScript and like the biggest, baddest graphics processors out there, you're able to take full advantage of them. But that being said, so GPU.js, what it does is it takes your Java, you write very simple JavaScript, and that JavaScript, it's like, when you're doing matrix transformations, which essentially is what we do with GPU.js, you have to start with writing loops. So you write, for Z, for Y, for X. You have 3 loops deep for whatever you're trying to calculate. And GPU.js, what it does is it like basically removes those loops, and you just take that code that will be inside of those loops and you stick it in a function, and that function runs inside of those loops on the graphics processor. So that would be like your thread, and each thread is separate. Like they all have to be calculated individually. But the biggest thing is that by JavaScript being so simple, we actually can parse the JavaScript into its individual parts and then actually take that one-to-one and measure it to a different language. And really the language doesn't matter so much. Right now it's GLSL, and then by relation WebGL or Headless GL or even WebGL2, to basically insert variables so that it works. right? It's like you have to give a variable to the graphics processor so that it can do something with it. But by actually reading all of the JavaScript, again, because it's so simple, we basically have that capability, and it's not magic. It's actually quite, let's see, what's the term? This would be a good place to put edit. It's resilient. It's super resilient because JavaScript is so simple. And even more, what's impressive about it too is with TypeScript, you have types. That's great. But as soon as TypeScript is compiled, you lose all of that. You have none of it available for JavaScript because JavaScript doesn't have types. So GLSL and pretty much anything that runs in a graphics processor has types, needs types, must have types. So there's no escaping it. And so by reading the variables that come in, right, you can actually go strongly typed inside of this, plain JavaScript, and it reads it all out to what's required on the graphics processor. I probably sound like I'm going too deep into GPU.js, but I have such an understanding of the entire framework. It was written by these guys in Singapore in 24 hours. It was planned probably months in advance. Like they had talked through how they were going to build it and what it was going to do. But they actually wrote it in 24 hours and spent considerable time in it afterwards. But they basically the project kind of got into a dormant state where they just didn't have time to maintain it. And when I found it, because I wanted JavaScript neural networks, not neural networks that were exposing a JavaScript API that were written in another language. Mm-hmm. And even though this is written in another language in part because it's compiled to that, you compose in JavaScript. Everything's composed in JavaScript with Brain.js. And so GPU.js, it takes full advantage of the graphics processor, and so all you need to know is simple JavaScript.
Clarify a couple of points then. So you write all of your code in JavaScript if you're using GPU.js.
Yeah.
And then it transpiles it down to C or C++ or, GLS. I don't know if that's a language or just kind of a way.
GLSL is it's like a sub, I forget the terminology. It's basically C++.
Okay. Mm-hmm. And, I have to, it's obligatory because I think it's funny that everything transpiles to JavaScript. So I love that JavaScript now transpiles to C++. But I really, really love the idea because that's the thing that I run into. I mean, I do a lot of Ruby, I do a lot of JavaScript. I've been playing with Elixir and stuff, which, it still runs on a virtual machine. And so it's pretty darn fast, but it's not like right on top of the metal like C++ is or C is. So yeah, anyway, I really love this idea where it's like, hey, just approach it in a high level language that you know, right? And you don't have to understand all the low level stuff, all the underlying stuff that, could impact this or not. And you get kind of the real close to the metal experience without having to write a real close to the level language where you have problems with like pointer arithmetic and stuff like that. That's where I see people get tripped up with that, is that there are foreign concepts in there and they're going, Python doesn't do this, right? So
yeah, it's been super eye-opening because you start to realize like the language matters very little. It's more about the capability. Like if you can give somebody the capability of writing those really complex GPU operations, and too, like it seems like so foreign. Even though it's like part of our daily browser experience, we may see WebGL in our browser.
Yep.
But writing really good WebGL is hard. It's really hard. Mm-hmm. And it takes a lot of time to get right. And by having a tool that just like does it for you, because we've looked at the profiling and we've made sure that I don't even know how to write good WebGL.
Right.
Yeah. So one of the other concepts in the article was that you wanted it to be so simple that a 10-year-old could do it kind of thing, right? With a little bit of mathematical knowledge and a little bit of programming skill. Do you think you've achieved that?
Like,
and if not, what are the steps?
Well, let's see. Do I think I've achieved it? I think the API that we have built has been thought through. The API in Brain.js, yes, I believe that a child could use it with little understanding of programming. I'll leave it at that.
Nice.
So that ties into now you also have a significant hand in Brain.js. Which is now able to utilize this kind of stuff. So I guess, can you talk a little bit about your adventure that brought you into Brain.js, which sort of like, I guess, brings us back to machine learning. So you totally kicked butt. I have to say, there's like a animated GIF from some TV show where a person like tries to turn on a light bulb burns out. So they're going to go do like
I
the
know where you're
next
going,
thing,
yeah.
and then like that has the next thing and next thing. Next thing you know, like somebody
They're
comes
shaving
in
a
and he's
yak.
like working on the car, and they're like, the light bulb's burnt out, and he's like, I'm working on it. Like
Yeah.
each thing led to the next. So you went deeper into it, solving like handling efficient JavaScript. So to bring us back to, I guess, what would be a little bit more of the light bulb, and maybe it's not the light bulb of the situation, but you did like a course on Brain.js. You got involved in Brain.js. Can you talk a little bit more about your role there?
Sure. Yeah. So if people are saying that machine learning is the next electricity, and not everybody's saying that, some people are saying it. I think one guy said it.
I think Andrew Ng said it, so now everybody says it.
Yeah.
So,
yeah.
to be fair,
yeah.
Once he says it, it's kind of like, all right, because a lot of people respect him.
So I'm thinking, the most ubiquitous language should have the proper machine learning tools. It shouldn't just have toys. And so I'm like, okay, but I got to understand it, because I asked the question, like who and how or when. Brain.js, I arrived at, was the simplest API that I could find. And it was also like really well respected. Tons of people used it for different things. There was people using it for farming equipment, of all things. Actually, it was super inspiring to me. Like that. I mean, because if you could give back, we all eat things that come from the earth. But I saw that, and Brain.js was abandoned, no maintainers or anything, or unmaintained, it basically said. I don't want to really get into the backstory of that, but focusing on that it was unmaintained and that you could fork anything, GitHub. So I was like, all right, let's just fork this thing and continue and fix some of the issues that were there and see where we can go with it. Because the API was just so attractive to me that it was like a couple of functions deep and you were at the math, right? That original thing that the professor would write on the chalkboard. And that to me just spoke volume. To this day, it still like drives me, because as soon as you add more layers of abstraction, you're just pushing the understanding further and further away from anybody being able to get at that and to understand it and to master it. And how often it is that people are like, I have no idea how machine learning works, when in fact it's just a bunch of matrix transformations. I mean, that's multiply, add, and then your activation.
It's like high school math, except for the derivatives.
Right. Yeah, the derivatives are kind of like the hardest part.
My son, I have an eighth grader, and he's always like, I hate math, and I'm like, you realize your whole life runs on math, right?
So depressing.
and I love this idea, right, of just getting down to the basic concepts, right? Because and every time there's a new thing, right, it's like, that sounds so complicated. I do this, right? There's a new library in JavaScript, or a new library in Ruby, or a new library in React or Vue when I'm playing with those, and it's like, it just seems so big. And then I start implementing it, I'm like, this isn't so bad.
Yeah.
So I'm loving that concept, right, where it's I go a couple functions deep, and there it is, right there.
Yeah. If you can do that, people just like, well, that's TensorFlow JS is mentioned everywhere and came about after Brain.js. But Brain.js is generally mentioned with it.
Yeah.
And the only, if you look at the developer, we're just a few people like working on this library. And the only thing we're trying to do is focus on the simplicity of it. Where TensorFlow JS, not that it's bad, but it's got a lot of money behind it and a lot of time and a lot of developers that are working on it. And so if you can speak to simplicity, it just is such a driving force for anything.
Yeah, that's actually pretty funny, because Brain.js got on React Native before TensorFlow JS got on React Native. They just got able to do React Native for TensorFlow JS, and that was like a person's full. I mean, like, great work. I love the work that they're doing. But also, like, to solidify your point, you've had a React Native Brain.js example out for over a year now, I think, and people writing articles about it. So, and I know that I implemented it, I want to say like 6 months ago in React Native. So it's been a really cool tool, and like, just seriously, like, down to it. And to come back to like the kid thing, right? Like, where everybody starts, like, when I was a kid, I hated math too, because like, I didn't think it had to do with anything.
Yeah.
And now I'm grown up and I love math because I know it has to do with everything. So it's sort of like this grow up moment for a lot of people.
I want to interrupt that and say you were the most childlike grown up. But you like celebrate it like every day. Like,
yeah,
it's like,
that is true.
Let's play,
Facts.
That's high praise, though, right?
Yeah. And I hope that comes across as a compliment.
No, I think that I'm going to keep that as long as I can, man. And the day that somebody doesn't say that, that's a problem.
You got to hold on to that. That's super important. I'm like you too. Like I hated math growing up.
Yep.
But now when I see those equations and you see everything flowing, man, that's just, and to be fair, like a neural net, like somebody's going to listen to this later and they're going to be like, yeah, well, I mean, these guys obviously don't know what they're talking about because there's so much math inside of a neural net. Yeah, there is a lot of it. But when you start pulling each of the parentheses apart, each of the actual equations apart, eventually you run at there's an operator with two numbers on either side. There's a lot of it.
It's machinational in math. It's not like it's not like taking integrals or where it's not like this art form in some sense. It is perfect for computers and bad for people.
Yeah. It's just I was venture to say it's sophisticated, right? There's a lot of math, but once you get down to those finite parts, you're just talking about very simple matrix transformation.
Yeah.
I think the way you've kind of demystified machine learning is, I think, a huge win. When I was postdocing, there was a professor that came to me and said, "Hey, I'm running this robotics class for undergrads, and I want to introduce some machine learning into it." And I very foolishly tried to talk him out of it because I was like, "Well, those kids don't, they haven't taken linear algebra or calculus or anything, and there's really no way to understand gradient descent without that background." And he said, "Well, but isn't there a more intuitive way of approaching it where you just describe it as like a repeated process of nudging the weights in whatever direction gets you closer to the performance you want?" Right? And I was like, "Oh, yeah, I guess so." And that kind of changed my whole philosophy, my whole outlook on this. And I think you've really, like that's what you've done, right? Is you've made this really accessible. You've explained it in a way that anyone can kind of tackle. Could you kind of talk about the process that you went through of realizing that was necessary and how you worked towards it?
Sure. When I look at something that doesn't make sense, it hurts. Like mentally, I think it's a tick with me. It's probably.
So how do you deal with Kesha, TikTok? What do you think?
It's just pain. That's like all right. When I looked at Brain.js, I didn't see complicated math. I saw something very simple algorithm that was probably 15 lines long for the feed forward part. And I was like, wait a second, it can't be that simple. Could it? And then I looked at the back propagation. So there's two means of sort of getting a network to run. The forward propagation is the easy part because you're just like guessing based off of weights, kind of like what Eric mentioned, how it sort of pulls an understanding of what's coming in towards a bias. The back propagation kind of like says, hey, you were wrong, and this is by how much, and here's how you should change. And then I looked at the back propagation, and it was like, I don't know, 17 lines long. And I'm like, you got to be kidding me. That's how complex machine learning is. Like those two algorithms. And for me, I was like, okay, so that's Brain.js at the time had a feed forward neural net. And I was like, well, there's this other thing called recurrent neural net. Like, how complicated is that? It's a little bit more complicated, but really it's not. And there's just more math, that's associated with it. And so like arriving at how simple it was just seeing those operations and knowing that add, multiply, and activation were basically all the steps that there are. I mean, there's quite a bit more that add to that, but when you're just saying, like, for example, inverse, or all of them are the point is that they're just simple math operations. And once you know one, by segregating that math operation into itself, you can just see how simple it is. And by relation and by good design, you see that the others are simple. And I don't know, that was just kind of like the polarizing effect that Brain.js had on me. I guess I don't really know. I didn't realize it was so simple. It was more of a discovery thing. Wow, there it is. It's so simple. Let's apply that everywhere. And by doing that, we're able to stay 3 levels deep of abstraction so that anybody can look at the nuts and bolts of the thing and see how it works.
Yeah.
Oh, that's really cool.
Yeah, I think that when it can be contained, right? It turns into its own symbol. And I think that that's the thing. Like symbols for people have power, and you have just this equation and this sort of section. When you can get your hands around it, you start saying I understand this, and it's easy to I want to use this.
Mm-hmm.
I feel like that starts to be the romance for most math. You start to see something where you're like, oh, okay. Especially in programming, we get to actually do that a bit more. I have my little tricks and my little codes and my little stuff like that. And while they might look alien to other people, they're my little tricks. Everybody's got their own hello world.
I agree with that.
You've got, when you break it down, you get in there. If it bothers you when it's complicated, and then once it's simple, like you have this aha moment. And I think like seeing that through, like not to spoiler alert your blog article, but it's don't give up. Don't give up. Get to that moment, And I think that's a great
simplify.
moment.
Well, if we can write it on a board, like on a chalkboard so easily, then we should be able to emulate that with the software so easily.
Yeah. Well, exactly.
And so, like, why not just embrace that math and try to adhere to the math rather than thinking of this giant API that does not only knows
with poorly named variables almost always, right?
Yeah, and just like, for example, a layer in Brain.js is not the same thing as a layer in TensorFlow.js. Like a layer in TensorFlow can have an activation, where an activation is a mathematical operation.
Yeah.
And so just separate them. Like, what if I want to activate twice? What if I want to activate and unactivate? Or like, I mean, who's to say we can do whatever we want? Or what if we activate 3 times? I mean, good grief! Like, thinking here. Or we could activate.
I think that you create a superhero if you activate too many times. Unless it's sigmoid. In that case, you can activate all day and just nothing that's coming out of it.
But that's a good question, though. Like, maybe this question comes from my ignorance and not having a strong development background. But how do you find the balance between having an API that's dead simple to use and understand, but still giving people the ability, like the flexibility to customize and tweak? What's your approach to that, especially in JavaScript?
It always starts with what the API will do, what it will give us. We never start like working at the math and then backwards. It always has to be will it be useful? And once we can see that there's a practical application for these very few lines of code, we just start like ripping it apart and start like matching where those. There's a really interesting thing on Netflix actually that I just saw. It has to do with design, like an abstraction of design or something like that. There's this awesome architect. He's like this brand new architect. He's doing all these crazy, beautiful buildings. And one of the things he mentioned is like getting everybody's input, everybody across the board, and uncompromisingly adhering to everybody's requirements, period. And I mean, if anybody has something negative to say, just embrace it and be like, okay, cool. That's all right. That'll be a part of it. And part of my background too, a lot of developers from a certain part of the world speak very negatively. This is probably racist. I hope it's not. But depending on somebody,
it's Canada, isn't it? It's Canada you're talking about.
Man. But I started to think we're all saying the same thing. They speak at it from a different point of view. Like they may attack it from what it doesn't do, or somebody else may attack it from what it does do. And I actually really embraced that and really liked it because from it comes amazing designs and designs that everybody's happy with. And so just doing that with Brain.js, saying, what will it allow us to do? Is it simple? Does it prevent us from just abstracting away into nothingness? Or does it keep the abstractions close to the top? And requiring everybody to have a proper input and not ignoring anybody, like you get a fantastic API.
Very cool.
Dang Canadians.
I feel really bad about saying that.
Where does and I can pick on Canadians. My grandpa was Canadian. Where does Brain.js go from here? Because it sounds like you're trying to keep it simple. And when people talk about that, a lot of times it's more what they're not going to put into it, or what they're not going to add to it, or what they're not going to complicate it with, than it is what they're going to put into it. But a lot of times there are improvements that you can put in, and it's really just threading the needle between simplicity and functionality. So what are you working on? Where do you see this going?
So a big hang-up just recently was code coverage of all things. I want to see everything be covered. I want to know, and it's really hard to do with the graphics processor. Like when you introduce the graphics processor into the thing, Istanbul is like the thing of choice that everybody uses for code coverage, and it did not work for Brain.js. I had to find a way to link it up or filter it out depending on the requirement for the unit test. And so V2 of Brain.js is going to have a brand new sort of API that allows us to compose neural nets. And those APIs are for recurrent and feed-forward and convolution. And so that'll be V2, and that's going to embrace the GPU in its entirety. Some of the the older classes that are there. They won't take advantage of the GPU. They'll just kind of still be around. But the idea is that you can now compose brand new sorts of neural nets that you never even thought of. So you could have a feed-forward, recurrent, convolutional neural net, whatever you want to do. And then V3, we're going to introduce reinforcement learning. And so that's the focus. We get reinforcement learning and the vision's done. And then we can play chess with Brain.js.
Well, I can tell you this. If you finish reinforcement learning, I will give you a cookie.
And I will appreciate that.
And I will ring a bell at the same time. Reinforcement. Bad psychology reinforcement jokes.
There we go. Pavlov's library.
Right. That's how I keep my hair so nice. Classical conditioning,
Oh no.
Oh boy. I think we're I thought the dad jokes were my job.
Oh no, I'm a new dad now, so sorry. You're gonna have to share.
That's right. You've got to try out all the old ones. Okay, that's fine.
Congrats on that, by the way.
Thank you.
Mm-hmm. Yeah. Here,
So-
Robert, do you have any success stories or that you want to point out, people that have used it to do cool things?
Thinking, Brain.js, cool things. I mean, I get people that just email me occasionally. They're like, hey, I love the library. Thank you. I got one yesterday from a guy that he ported it to C.
Wow.
He started in JavaScript and ported it to C. So that's pretty cool. I'd have to go through my list to find out. I get regularly people that use it for, sorry about background noise. And I don't know right off. My mind's drawing a blank.
Well, I can tell you, man, I found, so trying to use Brain.js when I first started trying to use it, I found blog articles. I found cool stuff about it. Also, you are extremely accessible as a person about it. If you actually start using Brain.js, you find lectures by Robert, you find like the online courses, you find them inside Slack rooms. So it's pretty good because I'll have to say, like, you help a lot of people use it for sure. And so like I see the cool experiments people are doing with it, and I can see the applications that people could be using Brain.js in a bunch of places. And I know that GPU.js is going to have a lot of application as well. So even if you don't get to hear those stories enough, you should, because just looking around, people are writing articles about the stuff that you've done.
Yeah, thanks.
Yeah,
Well,
I agree. I hear a lot of chatter about this too, and just by making, just the fact that you made it accessible to JavaScript programmers, that alone, right, has just opened up a whole new world of ideas and applications.
Cool. I just remembered one.
Yeah.
So there was the recurrent capabilities that actually came from recurrent.js. It's another library. We took the API that was there and sort of like melded it into Brain.js's so that it was spoken kind of like Brain.js. And then that sort of set up the precursor into, now we need the graphics processor and then building the new API for the ability to compose neural nets, rather than just have like an API that composes them internally for you. One of the guys reached out to me on Brem. He was like, can we use this thing to like to do stock market evaluation? I was like, I guess you could, I mean, it's machine learning. Like you can use it for just about anything. And he comes to me like day after day and he's like, yeah, so I started breaking down like these stock market things and it's not really working for me. And I was like, well, you just have to, you're feeding it one long line. And so that's kind of like fragile. You need to break it up so that it can see like patterns and things like that. And then, so we're talking about the API and days pass and eventually like he's making money off of like watching the stock market and like projecting things. And then I never heard from him again. I hope he's okay.
He's on his yacht in the ocean.
Yeah,
Right, again in a
struck
week.
it big. That's right.
To be fair, he implemented Brain.js so he didn't have to talk to people. So
Nice. Well, anything else we want to dive on here? You were saying something, Robert.
That's it for me. I really appreciate you guys asking these questions. I didn't know if it was going to be like specific, I don't know. I didn't know if it was going to be about GPU.js or Brain.js or really what to expect. So I really appreciate just kind of hashing all of this out, and I appreciate the praise too. But in that vein, there has been a lot of help along the way. A lot of people contributed to the library, and it's not just been me. So thanks to them, their energy, and for seeing that a library as simple as the one we're building can compete with those that are even more complex.
So do you have recommended hardware to run it on, or a setup guide or anything like that?
No. Just npm I space Brain.js, and you should have it.
Oh, good deal.
Nice.
Or yarn.
Don't start the npm yarn thing here. We don't want to activate Chuck.
Yeah, well, my usage of Yarn looks a whole lot like my usage for NPM. So, all right, well, let's go ahead and do some picks then. Gant, do you want to start us off?
Yeah. So picks are, just a fun, interesting thing that we want to kind of reference. And I'll say that yesterday I did a live coding session with actually the person we mentioned earlier, Vincent's Face API library. And I did it with Jason Langsdorff. So Jason and he challenged me to, he's like, hey, I want to Halloweenify my website. And he wants to be able to flip a switch and then basically have it add, different things to people's faces. So we brought in Face API. We did get stuck for about 20-25 minutes on his setup. He did have a yarn problem, but at the end of it, we wound up actually getting a really cool thing where we're adding this beard and glasses to people depending on where their face was. It took 15 minutes after we got the unstuck. And then he and I today, actually after this recording, so it'll be out by the time you hear it, we're going to go ahead and do a second recording live. That'll be today. And we'll actually add different masks. We'll randomize masks and pull pictures off. So ultimately, we'll probably end up making a cute little library where you can add this to your website and it'll find faces on the website and then put Halloween masks on top of them for you. We built this whole thing in real time with everybody watching and in live stream. So it's the Learn with Jason channel, and I'll definitely link you to it. And it was a lot of fun yesterday, and I guarantee it's going to be a lot of fun today as well. So that'll be my picks because I think that's a cute application of machine learning.
Nice. Eric, do you have some picks for
Very
us?
cool. Sure. This is kind of a random one, but just the other day I was at fast.ai, and there's a really good article on the front page there by Rachel Thomas about metrics and the use of metrics in AI. It's a really good read about how we often try to, we have some measurement of something that we care about, but then as soon as we make that a metric and try to optimize our system to achieve that, it ceases to be a good metric anymore. And I just thought it was a really insightful article, and it's a good thing, I think, to keep in mind for anyone who's getting into AI or even experienced practitioners. So I'd recommend that as my pick for this week.
Nice. It's like teaching to the test.
Yeah, basically, yeah. Even people who are experienced AI practitioners, we catch ourselves doing that a lot, and it causes all kinds of problems.
Yeah. Well, I think it's part of what makes people interesting is that we all kind of see a vision of where we want something to head. And even without thinking about it, a lot of times we wind up pushing the result that way. And so I see this as kind of an extension of that, but that makes sense. It's really, I'll have to go check out the article. I'm going to jump in with a few picks. So this last weekend, I was in Nashville. I was down at a get together for a bunch of guys that I talk to every week. We kind of split the difference between a professional mastermind and guys living life together. So we also talk about, we're all Christians. So it's all talk about faith. We talk about family. We talk about, life in general, all the things that go into having a good life. And we also talk about business. And I realized just how badly I needed to get away. And so I'm going to pick that. It's also interesting picking things knowing that this is probably going to come out on a little bit longer time horizon than I normally have. Because usually if I pick something, the episode will go live in a couple weeks on devchat.tv. But because this is a new show, we kind of just hang in there and get a handful of shows under our belt, get a regular recording schedule, and then get this out. So we're recording this on November 1st, 2019, and it's probably going to come out in late December, early January. Anyway, a few things that I'm working on, and I'll just throw it out there. So I am working on maxcoders.io. I think I talked about that before on the show, so I'm not going to belabor it. I also have a book coming out, and it's the Max Coder's Guide to Finding Your Dream Developer Job. And so if you're out there looking for a job that you don't seem to be able to either find one you want or, you just want something different, this book will walk you through figuring out what you want and then figuring out how to get in front of companies to get it. So I finished the book back this summer, but it's been interesting getting the cover together and the formatting done and all that stuff. So anyway, have that going too. And then we also put up swag. So I'll just put a link to that in the show notes, and you can go get shirts if you like this or any of our other shows. If you're getting into this just because of machine learning, we have a whole bunch of other coding shows. So go check them out as well. And then the last thing that I'm going to pick, my wife and I have really been enjoying this show, and we keep trying to watch the finale. And then we're like, oh, Netflix hasn't put it out yet, but it's the Great British Baking Show, or I guess if you're in Britain, it's the Great British Bake Off. But Bake Off is trademarked here in the US, so they couldn't use that, which I also find interesting. So anyway, it's just, I don't know exactly. It's one of those reality show contest type things where, they bake a few things during the show and then they get judged and then somebody gets kicked off the show. But the feel of the show is just awesome. And of course, I love looking at just what you can do with sugar, flour, eggs, etc. So it's a terrific show. I think almost all the seasons are on Netflix. there's been a little bit of interesting back and forth in the history there. It used to be on PBS and now it's not. And that has to do with it used to be on BBC and now it's not. So anyway, whatever you wind up finding with that, and when you see the host turnover, you can go look at what happened there, but still love the show. It's a great show. And the one thing that I love about it that you don't really see in a lot of the other contests or reality shows is that all of the people on there, and I think generally on all the other shows too, they're good people, but in this show in particular, you see them actually pull together and help each other. And so if something happens to one person's, dealio, and somebody has a few extra minutes, they'll go help somebody else, even though they're competing with them. And, they're pulling for each other and cheering for each other. And they're sad when somebody gets sent home. And anyway, it just feels really good to see that we may have to win at somebody else's expense, right? I stay in because you went home, but that doesn't mean that we have to, be mean to each other. So anyway, love that show. Robert, what are your picks?
What are my picks? That's abstract. I didn't know you guys were going to ask me.
Oh, it's
surprise, sucker!
Some people pick like fiction books. Some people pick TV shows. Some people pick tech stuff. So whatever.
So
like if you really love it, tell us about it.
So I haven't finished it yet, but the Abstract, the Art of Design on Netflix. I did not think I was going to like it, but I ended up loving it. And because physical world hardware is very similar to software if you're doing it right, or at least I think it is. And most people I've talked to, seem to share that. But it's pretty cool. I'm about halfway done with it. And anything that Gant is doing.
Oh man!
Yeah.
All right. That's it. I'm now officially a Robert fan forever. That's the nicest thing anybody's ever said to me.
I'm going to pick people that love you for saying nice things about them, which is pretty much everybody. So, all right, Robert, if people want to find Brain.js or find you online, usually we're looking for like Twitter, GitHub, or something like that. Where are the best places for people to reach out to you?
Twitter and email or Brim. There's, BRIIM, machine learning and JavaScript movement. It reminds me of how the British baking show you just mentioned?
Mm-hmm.
I just forgot the name of. Like JavaScript it seems like kind of like that. Like we just want a simple language and we're here to help each other. And so that's kind of like a really cool place to interact. Yant's there too.
Yeah.
Huh, I'll have to come check it out. What's your Twitter handle?
Robert L. Plummer. 2 M's.
That's easy. All right. Well, I don't think there's anything else. So let's go ahead and wrap this up.
All right.
All right. Max out, everybody.
Max out on the bench.
Oh, man.
Robert, thanks so much, man, dude, that blog article is epic. All this stuff is epic. If y'all want to watch me and Jason flounder around, actually, we're going to make it work this time. We did that thing for an hour and a half yesterday, and his stupid yarn stopped us for like 20 or 30 minutes. That killed everything. That's why we're doing a session today. We're just going to finish it up. But now that's all fixed, we'll probably have that. We're going to do a live streaming session in an hour and a half. Yeah, awesome. So if y'all want to, I'll share the link. Well, I'm sure I'll get the link. Just follow it. Check out Twitter in the next hour. I'll be posting it out there, but we'll be doing a live stream. Hopefully we'll get like some really cool monster masks on everybody. It's a nice. Really easy task to do as long as you don't get stuck in yarn land for 30 minutes.
It's overcoming the obstacles that is the beauty.
Well, what's funny is that Jason has this live streaming like Twitch style thing, which has all these like weird things where the audience can like make noises and videos play. It's the most distracting and worst environment to code in I've ever worked in my life.
I'm so tempted to go to the store, buy a skein of yarn for like $2 and then just pull it all out.
Yeah.
Jumble it all up and then mail it to you and Jason and go, I saw your live stream.
It's gonna be fun. I guarantee you though, like it's gonna I last night I got a bunch of Halloween masks ready for today. I'm excited. We'll have at least this code running, and maybe this will be something like just a nice little NPM library, just like, hey, add masks to everybody, go. It'd be fun. Yeah, it's
very cool.
That'll be fun. Robert, thanks so much, man. Keep sending like updates too. Is there an actual like Twitter account for this one set up, or if not?
For what one? What do you mean?
Oh, for Chuck, is there like, do you do Twitter accounts like per show?
Yeah, per show. I do. I don't know that I've set one up for this show yet.
Okay. So. We could probably, once that's all set up, we could probably retweet and kind of say some of the cool stuff that you've been doing with Brain.js. And that'd be a great primer for when the episode comes out.
Yep.
Awesome. All right, y'all.
I'll see you guys later. Thank you.
Thanks so much. Hey, how was that shark? How's that shark, Robert?
Oh, it was awesome, man.
Oh
It's a
yeah,
whale
shark.
So this is kind of neat. My parents, as parents do, they're slightly like unhealthy.
Mm-hmm.
And my mom, she sees this shark, this whale shark. I mean, I don't know how big it is. It's like 35 or 40 feet long.
Mm.
It's only like half grown. But she's like, wow, that's so neat. And we just like, we're watching it. And then these scuba divers come in. And you can pay to like go scuba diving with the whale shark. And so my mom's like, I want to do that. And I was like, okay.
Wow.
You get healthy. This is the goal. I want you to burn this into your memory.
Yeah.
You get healthy, and I will pay for it, and we will go together.
Oh,
She's
that's
like, I'm gonna do
awesome.
it.
Wow, that's awesome.
So
Yeah,
nice.
that's so cool.
That's
So maybe
good.
like in a year or something, we're gonna go scuba diving. With
Good
some
opportunity, man. That's a good opportunity.
Nice.
Sweet. All right. Well, I'm looking forward to the photos of you swimming with the whale shark and your mom. It'd be awesome, man. All right, everybody.
Yeah. If I did that, my mom would be like, I'm healthier than you.
No, that was really cool. Thanks, Robert.
Yes, indeed. All right, everybody.
I mean, like we've had TensorFlow JS for a while, but there's a lot of inanity with that, right? Like you have to specify so many things that really should just be abstracted away. And I feel like you really you strike a much better balance with yours.
Yeah, it's way better. The trick with TensorFlow JS people, I'll say, is like that they had to move it towards TensorFlow because like TensorFlow has constantly been getting kicked in the teeth by like, I mean, obviously they're moving towards like Keras and stuff. Like for a while now, they've known just like how unusable it is. And they're part of a large corporation where they're like having to make things kind of all like come together so they can still sit under the TensorFlow umbrella. And what you get to do is say like, wouldn't it be nice if it were called this? And there you go. That decision was made without a boardroom.
Yeah. Well, I mean, I still like, I'll propose.
Yeah.
Issues and people have the freedom to. I mean, a lot of people don't, obviously, but usually the people that are watching the library that have that's interesting to them, they'll say, "Well, this should not be that, or it should be this." But yeah, I agree. Sometimes you got to start from scratch.
Yeah,
or not scratch, but at an unmaintained state.
Yeah. Let me call my boss, and then I call up my wife, and she'll tell me to do whatever I want, and then I'll say, "My boss says it's my decision," and then I'll tell them what I think.
All right, it was good catching up with everybody.
Yeah,
I'll talk to you all soon.
Yeah.
Thanks, everyone.
Bye. Cheers.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.